Hey there, this is Alex, and in today's video I wanted to talk to you guys about some helpful terminology, concepts, and tools that I wish I knew when I was starting off getting into the data engineering field. So I'll try to go over and give it a brief high-level description of every single terms and every single tool, so you can kind of have a good understanding of what's what and what pieces fit where. If you're interested in this and you're new into data engineering, I would recommend you keep watching. So let's get started. As data engineers, we work with data on a regular basis. And the first thing we should do is try to figure out what kind of data we have. And the answer to this question falls in one of two categories. We have structured and unstructured data. And the difference is pretty much in the name. So an example of structured data is something that we can expect maybe in a form. So you might have to go ahead, fill out your name, date of birth, maybe you want to have a social security number or a phone number. We have a rough idea of what the data is going to look like. And then we can store that in something like a table in a database. On the other hand, an example of unstructured data is something like a video or like a picture, whether we don't know if a user is going to upload like a JPEG, a PNG, a GIF, a PDF, what kind of file format is it going to be, how many channels is it going to have, how are we going to handle it. So that's what we mean by unstructured data. After we have a good understanding of what kind of data we have, we then need to figure out a way to store this data. So there's quite a few solutions to figure out what's the best way to store data. And that kind of depends on what kind of data you have and what's the purpose for you storing that data. You usually have kind of four main categories. We have databases, data warehouses, data lakes, and data marts. So what are the key differences between each one of them? So databases, which are probably the most popular ones, is what we use to store most of the time structured or semi-structured data, and it's used usually for a transactional purpose. So for example, if you were writing an application and you were to write data, you would use a database rather than a data lake if you have a form to store. On the other hand, if you need to aggregate multiple databases together and you want to get some insights and trying to understand, for example, how your customers are getting their orders, what are their trends in between customers and products, that's when you would want to build a data warehouse. And that's when you try to aggregate multiple databases together for an analytical purpose. We also have a data mart, which is a data warehouse, but has more of a specific business use case. So you can picture a data mart something like an aggregation of databases in a big corporation that has a specific business use case. Finally, we have a data lake. That's usually what we use to store more unstructured data. So maybe you have a video or pictures or PDFs. That's when you would use something like S3 or Google Cloud Storage Bucket, something like an object storage format to store all of your unstructured data. After we have a good idea of what kind of data we have, what's the purpose of it, and how we're storing it, then we need to figure out of how do we actually want to process this data. So you might have heard of some data processing requirements like ACID transaction, OLAP, and OLTP. So what do all these acronyms actually mean? So ACID stands for atomicity, consistency, isolation, and durability, which are some standards that are enforced on database transaction. So if you were to write a MySQL query, it usually follows these ACID requirements. So a MySQL query is atomic, which means that if at any point the query fails, the whole query is going to fail. And then consistency means that once the query is written, then every single write afterwards is going to be exactly as the query made the change happen. Finally, we have isolation, which means that if we're writing to a row, we can have multiple pretty much writes at the same time. And then durability means that after we made a change, that change is going to be persistent, and we're going to make sure that that change is going to stay there after it's done. So the change is going to be maintained after the transaction is done. So what is OLTP and OLAP? So OLTP stands for Online Transaction Processing. And the key features of OLTP transactions are availability, speed, concurrency, and redundancy. So an example of an OLTP transaction is something like an ATM transaction where we want to make sure to have a fast, secure connection and to make sure that that transaction is going to go through. On the other hand, we also have OLAP, which stands for Online Analytical Processing. 3 key features on these requirements follow these 3 analytical operations. So we have consolidation, then we have drill down, and then we have slice and dice. For example, if we want to build any kind of insight tool, we want to make sure that it has this specific characteristic. Now I'm going to mention some of the terminology that I hear being thrown around quite often, but not being well defined. So, for example, what I hear quite often is key value data store. An example of this is a similar concept that you might have heard in something like Python or Java that you might be familiar with. So, in Python you might have seen dictionary, and this is exactly an example of key value data store. And in Java you might have seen hash maps. That's another example of key value data store. This idea is not specifically tied to a programming language, but it's more of an overarching idea of how to think about data. So other words that I hear quite often being thrown around are index and key, and this usually refers to a unique identifier that can point you towards multiple data points. That's kind of what we can use as a primary key to then identify multiple subset of a specific data set. Other concepts that I wish I was more familiar starting from the beginning are partitioning and caching, and these are in relation to optimizing querying. Partitioning is the idea of splitting a table in smaller subtable based on a specific column or field. On the other hand, caching just means the idea of storing the result of a query somewhere that it can be reused in the future, hoping that somebody is going to request the same information so you don't have to calculate the same information twice. If you're a data engineer, you probably heard the acronym DAG or data pipeline. And to my understanding, a series of steps, of processing steps that are going to be sequential, and that each one of the steps are not going to ever lead you to a previous one of those steps in that series. So that's pretty much all data pipeline or DAG is. So now I quickly want to mention big data tools, and I try to consider any big data tools a tool that I would use or try to introduce in my workflow if the kind of processing that I was doing wasn't sufficient for my use case. So if I'm trying to process hundreds of gigabytes of data in a few days, then I might do that with a Python script, and that's fine. But if I'm trying to do that in a few minutes or in a few hours, then I might have to go ahead and find a different solution. So some tools that I encourage you to look from the very beginning are Spark and Hadoop. Even though they seem very complex, they're a very complex ecosystem, I encourage you to try to go ahead and maybe try to have a high-level understanding of what's the use case for each tool, and try to follow a couple of tutorials and example, maybe set up a cluster and start practicing and do a little bit of hands-on. The tool that I encourage you to play with is Apache Kafka, and this is mainly specific to understanding how the streaming aspect of ingesting and processing data works, because this is slightly different than a batch processing, which means that you're going to process data in a chunked size. I also encourage you to check out the different cloud providers like Google and AWS, because they also have their own big data tools that fit their own specific use case. So Amazon is going to have their own Hadoop setup, and Google is going to have their own as well. This is an overview of the concepts and tools that I wish I knew at the very beginning of my data engineering journey. So I hope this video is helpful for some of you out there that are trying to get their feet into data engineering. And I hope that this kind of helped you understand some of the basic as well as some of the tools that are out there, and how you can go ahead and understanding the world of data engineering and how to navigate the different tools on all the different requirements, the different acronyms, and all that kind of good stuff. If you're interested into these data engineering concepts, let me know if you have a specific one that you want me to dive deep into a video later on. If you guys have any questions on some other terminology that you might have encountered, some other acronyms you might come across, and I haven't mentioned them here, please let me know in the comments down below, and feel free to ask. Make sure to answer all the comments. Until next week, I'll see you guys then. Bye!